Hello, welcome to this video. In this video, let us solve one more problem on diesel cycle. Let us read the problem. An engine with 200 mm cylinder diameter and 300 mm stroke works on a theoretical diesel cycle. The moment I see that this is a problem of diesel cycle, I would first copy PV and TS diagram, or I would first write PV and TS diagram. Okay. So, this is our PV and TS diagram for a diesel engine. Now, we have been given that diameter and length. So, let me write that 200 mm cylinder diameter. So, diameter is 200 mm. So, 200 into 10 power minus 3 meter, or we can straight away say it is 0.2 meter. And length is 300 mm, that is stroke. So, that will be 0.3 meter. Works on a theoretical diesel cycle. The initial pressure, so initial pressure in our cycle is 1. So, P1 is given that 1 bar. So, 1 bar is 10 power 5 Newton per meter square, and temperature, initial temperature is T1. So, 27, we will convert that into Kelvin. 27 plus 273, that will be 300 Kelvin. Cutoff is 8% of the stroke, that is very important statement. So, cutoff is V3 minus V2 is, cutoff is 8%. So, 8% is 0.08, 8% of the stroke. Stroke will be V1 minus V2. Okay. That is what we have been given with. Now, we have been asked to calculate sub question A, pressure and temperature at all points. Pressure and temperature at all points. Okay. Sub question B, theoretical A standard efficiency. Okay. Sub question C, mean effective pressure. Sub question D, power of the engine. So, in order to calculate power, we have been given that 380 cycles per minute. So, whatever we calculate is for one cycle. So, we will have to get multiply that by number of cycles per time, so that we will get power. Now, we have been given that the value of compression ratio is 15. Compression ratio is 15 and working fluid is air. Okay. So, these are the things which we have been given with. Now, what we shall do is let us start from pressure and temperature at all points. So, we will make a table and try to say all pressure and temperatures are listed in that table. Okay. So, we will have a table where we tabulate these answers. So, we want to find out pressure and temperature at 4 points. After all, we have 1, 2, 3 and 4. P1 and T1 are given, so that I will write. So, this is 1 into 10 power 5. I would say this is in Newton per meter square and temperature is in Kelvin. So, this is known to us 300 Kelvin. Now, let us go for P2. So, in order to do that, I think we shall start with P1 process 1 to 2. Process 1 to 2, P1 V1 power gamma is equal to P2 V2 power gamma. Okay. Now, therefore, this is P1 V1 by V2 power gamma. So, this we know it, P2 is equal to P1 V1 by V2 is R power gamma. So, P1 is 1 into 10 power 5 and the value of R is given to us 15 and gamma for air is 1.4. So, this must give us the value of P2. Let us find out P2. 1 into 10 power 5 multiplied by 15 power 1.4. So, this is 4.43 into 10 power 6. 4.43 into 10 power 6. And for 6 Newton per meter square. So that is our pressure after compression. Now similarly, same process we'll use and try to find out the value of T2. Now same process 1 to 2, let us use to find out T2. So that is P1 V1 power gamma is equal to P2 V2 power gamma, and we want temperature ratio. So I will eliminate let us say volume here. So because we do not have the volumes anywhere, so it is better to eliminate volume. So V is equal to mRT by P. Okay. In place of volume, I can represent T by P because mR will cancel out in both the sides anyway. So P1, now this volume, since we have a compression ratio, we can also use this ratio for finding out temperature. Okay, let us do that way only. So PV is equal to mRT. Let us say in place of pressure, we can go for mRT by V. That is also fine. So both are good. So P1, in place of P1, I am substituting T1, right? So T1 by V1. Okay, MR cancels out, so we'll neglect it. So V1 power gamma. P2, we can go for T2 by V2, V2 power gamma. Now we'll have T1. This, if it goes to the numerator, V1 power gamma minus 1, because V1 power minus 1, then the powers will be added. Similarly, T2, V2 power gamma minus 1. So this will be T2 is equal to T1 V1 by V2 whole power gamma minus 1. Okay. That is nothing but T2 is equal to T1 V1 by V2 is R power gamma minus 1. So T1 is known to us 300 and R is known to us, compression ratio is 15. So 15 power 1.4 minus 1. So let us get the value of T2. 300 into 15 power 1.4 minus 1 is 0.4. So T2 is 886.25. 886.25 Kelvin. So this will be our T2. Okay. Now let us write this in our table so that we'll not miss out any values. So this is 4.43 into 10 power 6 and T2 is 886.25 Kelvin. And remember, P2 is equal to P3. Look at our diagram. Pressure is constant between 2 and 3. So P2 is equal to P3. So this is 4.43 into 10 power 6 because P2 is equal to P3. Okay. 4.43 into 10 power 6 Newton per meter square. Now, in order to find out T3, let us take process 2 to 3. Now, what is constant? Pressure constant. Now, process 2 to 3. Process 2 to 3, pressure constant. Now, pressure constant means we can also write pressure constant is something like this. PV is equal to MRT. Pressure constant means V is equal to, I'll send this temperature to the left, V is equal to MR by P. So the whole right side is constant because M is always constant for a closed system, R is constant, pressure is constant anyway for this process. So V by T is equal to constant for a pressure constant process is also true. So V2 by T2 is equal to V3 by T3. This we can do. So in order to calculate T3, only unknown should be T3 here. So that will be something like I will send this T3 to the left side, then we'll have V3 by V2 here and T2 here. So this we had done it in our derivation also. So T3 is equal to T2 times rho, or rho times V3 by V2 is rho. So this we can use. So this we can be solved only when we know the value of rho. Now can we find out the value of rho from here? I think yes, because we have been given with this equation. This equation is known to us. So I will use that equation to find out the value of rho. So let us use this equation to find out the value of rho. V3 minus V2 is equal to 0.08. V3 minus V2. So the idea is find rho. To find rho, V3 minus V2 is equal to 0.08 times of V1 minus V2. So we can take out a V2 common here, that will be V3 minus V2 here, so rho minus 1, 0.08. V2 if we take common here, this will be V1 by V2 R minus 1 here. So V2 cancels out. So rho is the unknown, rho minus 1 is equal to 0.08, and compression ratio we were given with the value 15 minus 1. So the only unknown is rho. I think we can calculate the value of rho. So alpha x minus 1, alpha equals 0.08 into 14. 15 minus 1, 14. So we'll shift, solve for x is equal to 0. We'll have rho value 2.12. So rho value is 2.12. Now using rho value, we can find out T3. So let us calculate T3. So therefore, T3 is equal to 2.12 multiplied by our T2 was 886.25. 886.25. 2.12 into 886.25. That will be 1878.85. 1878.85 Kelvin. So we have found out T3 as well. 1878.85. Now let us go for P4 and T4. So I think it is better to go for process 3 to 4. So I will use process 3 to 4. Process 3 to 4. So using process 3 to 4, we can write P3 V3 power gamma is equal to P4 V4 power gamma. Now P3, we want to find out P4. So I'll simplify it for P4 is equal to P3. We have P3 value. Then this is V3 by V4. V3 by V4 whole power gamma. Now we neither know V3 and V4 separately. So we have used this trick even in our derivation as well. Now whenever we have V3 by V4, let us multiply it by V2 and divide by V2. Okay, and divide by V2. So nothing, we have not changed the meaning of it. We have just multiplied and divided by it. Now what is V3 by V2? V3 by V2 is rho. So P3, V3 by V2 is rho. And what is V2 by V4? What is V2 by V4? Look at this V2 by V4 here. V2 is clearance volume. V4 is equal to V1. All right. So we know that, I mean, this we are coming from, we know that V3 by V2 is equal to rho, and V1 by V2 is equal to R. Okay. R, we can say that V2 by V1 is equal to 1 by R, therefore. Okay. So V2 is okay, but V1 is what? V1 is V4. So V1 is equal to V4. Because V1 is equal to V4, we can say that V2 by V4 is equal to 1 by R. Okay. Because V1 is also equal to V4. Okay. Keeping that in mind, this can be rho by R whole power gamma. Now, I think everything is known to us. P3 is 4.43 into 10 power 6. 4.43 into 10 power 6, rho value 2.12 by r value 15 whole power 1.4. So, if we solve this now, let us solve this now. So, we will have the value of P4. Let us solve this now. 4.43 into 10 power 6 into 2.12 divided by 15 whole power 1.4. So, that will be 286.25 into 10 power 3. 286.25 into 10 power 3 Newton per meter square. So, let us write P4 286.25 into 10 power 3. Now, let us go for T4. Now, using the same trick to find T4. Okay, to find T4. P3 V3 power gamma is equal to P4 V4 power gamma, but let us go for temperature ratio because we are interested in finding out T4. So, eliminate either P or V. PV is equal to MRT. So, let us eliminate volume only. That is also fine. Anyway, it will give us the same answer. So, if we want to eliminate volume, we will have to replace volume by T by P. So, P3 in place of volume, I will go for T by P. So, T3 by P3 whole power gamma. Here P4 in place of V4, I will have to go for T4 by P4 whole power gamma. Now, what will end up with T3 power gamma? Now, this will go to the denominator P3 power gamma minus 1. Now, again here T4 power gamma divided by P4 power gamma minus 1. So, this will be something like P4 by P3 whole power gamma minus 1 is equal to T4 by T3 whole power gamma. Okay. So, if we do that, then okay, I will just keep it here. If we do that, we can go for T4 is equal to T4 by T3 is equal to P4 by P3. Now, if this gamma goes to here, it will be gamma minus 1 by gamma. So, this will be T4 is equal to T3 into this pressure ratio whole power gamma minus 1 by gamma. Now, what is T3 here? T3 is known to us 1878.85. 1878.85, and this P4 by P3 we have already calculated. P4 is 286.25 into 10 power 3, 286.25 into 10 power 3, and our P3 is 4.43 into 10 power 6, 4.43 into 10 power 6 whole power gamma minus 1, 1.4 minus 1 divided by 1.4. So, this must give us the value of temperature T4 at the end of expansion. All right. So, let us solve this. 1878.85 multiplied by 286.25 into 10 power 3 divided by 4.43 into 10 power 6 to the power 0.4, that is 1.4 minus 1 divided by 1. So, this must give us the value of T4 858.99. I will go with 859 Kelvin. So, that will be our T4. So, 859. 859 Kelvin. Okay. Now, we are done with all temperatures and pressures at all salient points. Now, let us go for theoretical A standard efficiency. Now, we know the equation for A standard efficiency is given for diesel engine by A standard efficiency is equal to subquotient B now 1 minus 1 by R power gamma minus 1 into gamma rho power gamma minus 1 divided by rho minus 1. Okay. So, that will be 1 minus 1 by, now R is 15 power 1.4 minus 1, I will straight away write 0.4. So, gamma is 1.4. Now, rho was we have found out the value of rho is 2.12. So, we will go for 2.12 minus 1 here, 2.12 minus 1, and here it will be 2.12 power 1.4 minus 1. Okay. So, this shall give us the answer for efficiency. So, let us solve this equation now. 1 minus 2.12 power 1.4 minus 1 divided by 15 power 0.4 into 1.4 into 2.12 minus 1. So, 59.77. So, 0.5977, but it has to be multiplied by 100. So, that will be 59.77 percentage. So, this will be our efficiency, A standard efficiency. All right. Now, let us go for subquotient C. Let us go for subquotient C. Now, what is asked in subquotient C? Mean effective pressure. Subquotient C, mean effective pressure. So, mean effective pressure is given by the equation equal to P1 R power gamma. So, this equation is known to us, which is derived earlier. So, let us calculate mean effective pressure using this equation. So, P1 is known to us. P1 is known to us. I will 1 into 10 power 5. So, 1 into 10 power 5, and the value of R is known to us 15. So, 15 power 1.4, and then we have gamma value 1.4 into rho is 2.12 minus 1, okay, minus R 15 power gamma minus 1, sorry, 1 minus gamma. So, is 1 minus 1.4, and then we have 2.12 rho power 1.4 minus 1, okay, divided by gamma minus 1, that is 1.4 minus 1, and R minus 1, that will be 15 minus 1. So, this is our equation. So, what I will try to do is I will try to solve this separately, so that we get I mean we'll split it and try to solve it. Do not put everything in the calculator and try to do it, otherwise it will be difficult. So, I will do this part separately, and then what is in the bracket separately, and then we will multiply. So, I would say 1 into 10 power 5 into 15 power 1.4. So, 1.4 divided by this will be, okay, 1.4 minus 1.4 into 15 minus 1 is 40. So, this is what is outside the bracket. So, 791.29 into 10 power 3. So, this is what is outside the bracket. Now, let us go to what is inside the bracket. So, here also I will do the first term separately. So, 1.4 into 2.12 minus 1, which will be 1.12. So, the first term is 1.568 minus the second term is 15 power 1 minus 1.4 into 2.12 power 1.4 minus 1. So that will be 0.6307. So this must give us the answer for mean effective pressure. So 791.29 into 10 power 3 multiplied by 1.568 minus 0.6307. So that will be 741.67 into 10 power 3 Newton per meter square. So this is our mean effective pressure. Now once we have mean effective pressure, I think next part we shall go for what is asked. Last one, power of the engine, all right, 380 cycles per minute. So now I think we can calculate this. We need to calculate work done. So what is work done? Work done is P into dV. So where P is mean effective pressure, dV is swept volume. Okay. Now swept volume can be calculated because swept volume data has been given to us, like calculate swept volume, because we are given with pi d square by 4 into length. So we have been given with the value of diameter and length. So let us look at the diameter and length. Now diameter is 0.2 and 0.3. So this is 0.2 square into length is 0.3. So that will give us the value of swept volume. So pi into 0.2 square into 0.3 divided by 4. So that is 9.424 into 10 power minus 3. 9.424 into 10 power minus 3 meter cube. Okay. So I will come back here. And substitute this value 9.424 into 10 power minus 3. So once we do this, I think we'll have work transfer in what unit? This was in Newton per meter square and this was in meter cube, meter square. Those of we'll have Newton meter, which is in joule. So answer will be in joule. Okay. So 741.67 into 10 power 3 into 9.424 into 10 power minus 3. So that will be 6989.4, or let us say 6.989 into 10 power 3 joule. Or if you divide this by 1000, it will be kilojoule. I will write it as kilojoules. Now power is what we wanted actually. So I will say that power is equal to work done multiplied by cycles per second. Will substitute because we want it in kilowatt. So work done is 6.989. This is in kilojoules, and if you substitute this in seconds, I mean cycles per second, we'll have it in kilowatt. Now what was cycles was given in per minute. Let us check. Cycle was what? 380 cycles per minute. So 380 per minute is converted into 60 cycles per second. So that will be 6.989 into 380 divided by 60. So 44.26 kilowatt. 44.26 kilowatt. Thank you.